Today we shall see the concept of star-delta transformation. When a circuit cannot be simplified by normal series parallel reduction technique, the star-delta transformation can be used. Figure A shows the three resistances RA, RB and RC connected in the form of delta network. RA, RB and RC. Let us name the terminals as 1, 2 and 3 and this as figure A. Similarly, we shall write figure B which shows three resistances R1, R2 and R3 which are connected in the form of star. So figure B represents a star network which is having the terminals 1, 2 and 3 and resistances R1, R2 and R3. These two networks will be electrically equivalent if the resistance as measured between any pair of terminals is the same in both of the arrangements. Both star network and dual network and delta network are dual to each other. Now we shall study how to convert a delta to star or star to delta. First let us go for delta to star transformation. Referring to the figure A, the resistance between the terminals between the terminals 1 and 2 is given by R1 plus R2 which is equal to RC which is in parallel with RA plus RB. That is nothing but when you are measuring the resistance across the terminals 1 and 2, RA and RB will become in series connection and this series connection will be in parallel with RC. So this will be RC into RA plus RB divided by RC plus RA plus RB. LHS will be R1 plus R2. Let us consider this as equation number 1. Similarly, the resistance between the terminals 2 and 3 is given by R2 plus R3 which is equal to RA parallel with RB plus RC. RB and RC resistance will be in series and this series connection will be in parallel with RA resistance. So this R2 plus R3 will be equal to RA into RB plus RC whole divided by RA plus RB plus RC. Let us consider this as equation number 2. Next, the resistance between the terminals 1 and 3 is given by R1 plus R3 which is equal to RB into RA plus RC whole divided by RA plus RB plus RC. Let us name this as equation number 3. Now equation 2 minus equation 1 becomes R2 plus R3 minus R1 minus R2 which is equal to RA into RC plus RB minus RC into RA plus RB whole divided by RA plus RB plus RC which is equal to RA, remove the brackets, RA into RC plus RA into RB minus RA into RC minus RB into RC whole divided by RA plus RB plus RC. On the left hand side you will be having R2 plus R3 minus R1 minus R2. Minus RARC and plus RARC gets cancelled. Minus R2 and plus R2 will get cancelled. Remaining term will be equal to R3 minus R1 which is equal to RA into RB minus RB into RC whole divided by RA plus RB plus RC. Consider this as equation number 4. Now, equation 3 plus equation 4 implies R1 plus R3 plus R3 minus R1 which is equal to RB into RA plus RC plus RA into RB minus RB into RC whole divided by RA plus RB plus RC. Minus R1 plus R1 cancels. So you will get on the LHS side 2R3 and on the right hand side you will get RA into multiply into the brackets. You will get RA into RB plus RB into RC plus RA RB. Remaining terms you write as it is minus RB into RC whole divided by RA plus RB plus RC. Now in the numerator if you observe you have plus RBRC minus RBRC both will get cancelled. So remaining terms will be 2RA RB whole divided by RA plus RB plus RC. Here 2 and 2 will get cancelled. Remaining term will be R3 which is equal to RA into RB whole divided by RA plus RB plus RC. Consider this as equation number 5. So in the star network if you want to find out resistance R3, then in the delta network RA into RB divided by RA plus RB plus RC will be the equation. Similarly you can find R2 and R1 in the same manner. If you find R2 equation will be equal to RA into RC whole divided by RA plus RB plus RC. R1 equation will be RB into RC whole divided by RA plus RB plus RC. Consider this as equation 6 and consider this as equation number 7. By observing equation 5, equation 6 and equation 7, we can say The star resistance connected to terminal is equal to the product of two delta resistances connected to the same terminal divided by the sum of the delta resistances. In the same way, now we shall see star to delta transformation. Consider equation 5, 6 and 7 that we got in delta star transformation. We shall now multiply the equations 5, 6 and 7. Equation 5 into equation 6 implies R3 into R2, which is equal to RA RB into RA RC whole divided by RA plus RB plus RC whole square. So you will get R3 R2, which is equal to RA square RB RC whole divided by RA plus RB plus RC whole square. Let us consider this as equation number 8 now. In the same way, multiply equation 6 into equation 7. We get R2 R1, which is equal to RA RC into RB RC divided by RA plus RB plus RC whole square. This will be equal to RA RB RC square divided by RA plus RB plus RC whole square. This is R2 and R1. Consider this as equation number 9 now. Multiply equation 5 into equation 7. R3 R1 equal to RA RB into RB RC divided by RA plus RB plus RC whole square. So when you multiply, you will get RA RB square into RC divided by RA plus RB plus RC whole square. This is R3 into R1. Let us consider this as equation number 10. Add equation 8 plus equation 9 plus equation 10. You will get R3 R2 plus R2 R1 plus R3 R1, which is equal to RA square RB RC plus RA RB RC square plus RA RB square into RC divided by RA plus RB plus RC whole square. In the numerator, you can take RA, RB, RC as the common factor. You will get the remaining terms multiplied as RA plus RB plus RC divided by the denominator RA plus RB into RC whole square. So one RA RB and another one RA RB plus RC will get cancelled. Now the remaining terms will be R1 R2 plus R2 R3. Just rearrange the terms in order into R1 R3, which is equal to RA RB into RC whole divided by RA plus RB plus RC. We know R1 is equal to RB into RC divided by RA plus RB plus RC. Substitute for R1 now. So this RB, RA, RB plus RC will now become R1. You will get R1 R2 plus R2 R3 plus R1 R3, which is equal to RA into R1 whole divided by just RA into R1. Therefore, RA will be equal to R1 R2 plus R2 R3 plus R1 R3 divided by R1. Where RA represents the resistance in delta network, R1 and R2 and R3 represents the resistances in star network. So if you know R1, R2, R3 in star network, you can easily find out resistance RA in delta network. So similarly, when you solve the other equations also, you will get RB, which is equal to R1 R2 plus R2 R3 plus R1 R3 divided by R2. RC, which is equal to same R1 R2 plus R2 R3 plus R1 R3 divided by R3. Thus, delta resistance between the two terminals is the sum of two star resistances connected to the same terminals plus the product of the two resistances divided by the remaining third star resistance. So now if you observe the delta and star network which I have drawn before, terminals 1, 2 and 3, RA, RB and RC. Here 1, 2 and 3, R1, R2 and R3. So this represents the star network and this represents delta network. If you just put this star network inside this delta network like this, where this is R1, R2 and R3. So here you can observe R1 will be equal to the opposite resistance, means opposite to that R1, RC into RB divided by sum of the resistances will be common, RA plus RB plus RC. If you come for R2, R2 will be equal to RA into RC divided by RA plus RB plus RC. Similarly, R3 will be equal to RA into RB divided by RA plus RB plus RC. This is some simpler way to remember star to delta or delta to star equations. Similarly, when you come for RA will be in the numerator, it is same, R1 into R2 plus R2 into R3 plus R3 into R1 divided by this RA's opposite resistance, that is R1. You can see in this equation. Similarly, when you come for RB, numerator is same, R1 into R2 plus R2 into R3 plus R3 into R1 divided by RB opposite resistance, that is R2. Similarly, when you come for RC, R1 into R2, R2 into R3, R3 into R1 divided by RC opposite the resistance that is present here divided by R3. This is one just simpler way for you to understand how to write the equations directly from delta to star or from star to delta.